Hey, what's up everybody? Today we're working on compound inequalities. Compound inequalities. What are compound inequalities? Well, before we cover that, let's just review what an inequality is. An inequality tells me that things are not equal. What do you mean they're not equal? Well, sometimes things are not equal, okay? Like, for example, 6 is less than 7. What? And you know that, like, sometimes 6 is afraid of 7, because 7, 8, 9. Sorry. So, anyway, if I was looking at an inequality, what does an inequality represent? Well, it represents that sometimes there is a limit to stuff. So let's say, for example, if I was going to try to go ahead and graph the number of sit-ups that I do every day. Well, I always know that I'm doing at least one sit-up as I'm getting up in the morning. What? So I know that the number of sit-ups I do every day, because I'm a mathematician, I like to graph this out. So I would write the equation connected, sorry, not the equation, the inequality, connected with the number of sit-ups I do as 1 is less than or equal to x, x being the number of sit-ups I do every day. So if I was going to graph that bad boy out, I'd go ahead and start with 0, and then I go ahead and get a 1, and so looking at these two, I could say that x is greater than or equal to, being equal to, I go ahead and shade that in. If you're not sure why I'm shading that in, you can go ahead and check my previous video on graphing inequalities. And so x is everything that is greater than or equal to 1. So according to this graph, I can do 1 sit-up a day, 2, 3, 4, okay, or 4,000, because there's no limit to what I'm doing here. Oh man, I know, because you look at this body and you think he must do thousands of sit-ups every day, and I would agree with you, except that's completely not true. Now, when I come to the fact that there is a limit to the number of sit-ups I can do every day, I then have what's called a compound inequality, okay? Which means that there's actually a limit to what I can do. And you're like, a limit? You with that body? And I'm like, yeah, you know what? Not unstoppable, even though it might look like that. So let's say that I have 1 is less than or equal to x, which we covered before, okay? And let's say that my upper limit is that I can't do 1,000 sit-ups, okay? So let's say I stopped at about 1,000. And I would say that x, 1,000, would be greater than x. Not greater than or equal to, because I can't do 1,000. Again, you're like, what? And I'm like, no, really, I can't do 1,000. But I could put these two together, all right, and I'd get a compound inequality. Kind of like when you have a compound sentence, you have two real sentences joined by and, or a conjunction of some other sort. So check this out. I would write this out as 1 is less than or equal to x, which is, wait a second, is x less than or greater than 1,000? In this case, x, number of sit-ups I do, is less than 1,000. So I'll mark it as 1 is less than or equal to x, which is less than 1,000. And I should put commas in when I'm marking in the thousands place. Got to watch out for that. So here is how I would graph this out. I would go ahead and put a 0, just so we have an idea. I now have a 1, and I'm going to be all the way over here at 1,000. Seems legit, okay? Actually, for those of you who are really into it, you should know that what I really should have is a break marker, which means that I'm like skipping, and I'm like 998, 999, and 1,000. But sometimes I'm just sloppy and lazy, which you should never do because you're a mathematician. You should be on point. So check this out. When I go ahead and I graph this bad boy, I mark these. So first of these, I say x is less than, or sorry, x is greater than or equal to 1. So I mark that in with a solid. And it's solid because it's included. X can possibly be 1, because I can do as little as 1 sit-up a day when I'm waking up in the morning doing that sit-up. Now it maxes out at 1,000, and I don't actually make it to 1,000, okay? So it does not include 1,000. I can't do 1,000 sit-ups, all right? And I think we already covered that. So the idea of how I would graph this is x is everything greater than 1, so I'm like, blue, greater, and x is everything greater than or equal to 1. And x is everything less than 1,000. So I'm going to come in this way, boom, and they meet in the middle. So this is the range of sit-ups that I could do every day. That is the idea behind compound inequalities, okay? So in the that's just the idea. And I think I can give you one more example. Can you handle that? No? Yes, you can. So here we go. I'm going to erase this. So we're going to erase. Now, let's say, for example, I give you, or your teacher gives you this compound inequality that looks like this. And you're like at -6, is less than, I don't know, let's go less than 2x plus 8, and which is, go less than or equal to 16. Okay, y'all ready for this? Now the way that I would solve this out, okay, I can do it two ways. One of the ways is that I could rewrite this bad boy. And I could rewrite it as negative 6 is less than 2x plus 8, and then also, in this case, we have 16 is greater than this. Does that make sense, that 16 is greater than this? So I could write it as 2x plus 8 is less than or equal to 16, or, and I hope I don't lose you on this one, I could put the 16 on this side and the 2x plus 8 on this side, and if I did that, check this out. The 16 is greater, right? I still have to write the 16 as being greater if I did it like this. Does that make sense? Okay. One of the nice things, though, and I gotta say this, is when you actually have your variable on the left side. Okay, when your variable's on the left side, all feels right with the world. And I'll explain a little why in a minute, okay? So let's say if I rewrote this bad boy, 2x plus 8 is greater than negative 6. So I could write it as 2x plus 8 is greater than, because it is, right? The open mouth, the alligator mouth, is still trying to eat the 2x plus 8. And I got negative 6 on this side. You cool with that? I hope so. Now I could go about solving. So what would I do to solve this? The first thing I would do is I would, what? I could go ahead and subtract 8 from both sides. Boom, 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 boom. Okay? Positive 8 minus 8 cancels out. Negative 6 minus 8 is going to give me a negative 14. Booyah-ka-cha. And then I'm at 2x is greater than negative 14. To finish solving this side, I divide by 2, division property of equality, and I get x is greater than negative 7. Alright, and I can graph that one in a hot second. I also have this side which I want to finish out. I subtract 8 from both sides, subtract 8, and I've got 2x is less than or equal to positive 8. Divide both sides by 2, division property of equality. I'm at x is less than or equal to 4. So then I can graph this out. Alright, when I'm graphing this out, I'm going to have my little number line. I've got a negative 7 over here. I've got a 0, and I've got a positive 4. Alright, y'all good for that? Now, I see one of these incorporates its open circle. It's open circle because x is not included, with the value of x is not included in negative 7. This one is less than or equal to, so it is included, and so that would be solid in. Okay? Now, x from this one, I would say x is greater than negative 7, so it's going this way. And this one says x is less than 4, so it's going this way, and I'm shading. Okay? Now notice this. When I have my variable, and this is the gold, when I have my variable on the left side of an inequality, the arrow always tells me which way to graph. Once again, if I have my variable on the left side of the inequality, it always tells me which way to graph. So looking at this, I've got x is greater than negative 7. And it's like going this way with the arrow, so I'm like, oh, I'm going to graph this direction. What? And then the other way, if I have x is less than or equal to 4, it's telling me to graph this way. What? And the included area is all of this action in the middle. So, I hope you find that awesome, because I know I do. Now I said there's 2 ways to solve this, and I enlightened you, so check this out. I'm going to erase this part real quick. Now, the other way of solving this, and I'm going to do the same problem again, but another way. So check this out. I'm at negative 6 is less than 2x plus 8, which is less than or equal to 16. Now, what if I didn't want to rewrite it and I just kept it like this, and I decided to do the same thing to both sides, because that's what I did. Remember, I subtracted 8 from either side. Do you remember that? You can rewind the video. I subtracted 8 from either side. So it looked kind of like this. I can be all like, what? I can subtract 8 from here, subtract 8 from here, subtract 8 from here. This cancels out. Alright? So now I'm at, what's negative 6 minus 8? We previously said it was negative 14. Is still less than 2x, because that's all that's left here. That's brought down. And then is less than or equal to positive 8. Then I can division property of equality this again. Boom! Bam! Pow! Alright? Cancels out. Negative 14 divided by 2 is negative 7, which is less than x. And then 8 divided by 2 is still 4. Okay? And so I can just have it written like this. And I'd say it as negative 7 is less than x, which is less than or equal to 4. Negative 7 is less than x, which is less than or equal to 4. Again, I'm graphing it the same way. But I don't have that wonderful moment where I have x on the left side of the variable. So it doesn't, I have x on the left side of, I said left side of the variable, on the left side of the inequality. One of my variables on the left side of the inequality, it'll tell me I'm graphing in this direction. But it's, not to get confusing, but it's opposite when I have it on the right side of the inequality. That's why it gets a little confusing. So to finish this out, I'd be at -7, I'd be at 0, I'd be at +4, and I would have to just know what I'm talking about, that -7 is less than x. So if it's less than x, then I got to graph the stuff greater. In this case, x is less than or equal to, solid circle, solid dot, x is less than or equal to 4, so I'm graphing the stuff that's less than or equal to. Still, we get the same answer. So those are two different ways of solving the same type of problem. So this is called an AND statement, because x is greater than -7 and it is less than +4. AND statements point in towards each other. So they're coming in at each other like that. AND statements are coming in at each other. Next video I'm going to show you OR statements where they're going like that. But this one's like an AND statement, okay? So it's coming at each other. So you're like boop, 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 and they're coming together just like that. It's an awesome dance. You can do it at home. You can love it. So, peace. That is compound inequalities. Hope you have a great day. Talk to you later.